Hello everyone, welcome back to my channel. Have you ever wondered how industries remove gases from exhaust stream like carbon dioxide, carbon monoxide, sulfur dioxide? Today we're gonna break down one of the most important topic in chemical engineering, which is absorption. So let's get started. So what is an absorber? Absorber is a column or a tower where gas stream is in contact with a liquid solvent, whereas one or more gases component can be removed or absorbed by the solvent itself. So in general, this process considered like a gas cleaning or a gas separation tower using a liquid. Unlike the distillation column, we're responsible for separation crude oil by difference in boiling point. But in this case, we is separated by we target a solvent whereas a liquid in our case. So we have like a basic diagram of how the absorber looks like. So in general, it's just like a simple column. It has like a packing bed, ration ring, anything to increase the surface area of contact between gas and liquid. And in this case, we have like at the bottom here, we have like a gas inlet, and uh, um, in most cases should be like a mixture of gases, and we have like a gases we need to be targeted to be absorbed by a solvent, and we have a solvent come from the top, and then both are in contact together on the packing bed, whereas the packing bed responsible for increase the surface area of contact and increase the mass transfer. And then the clean gas go from the top, and the rich solvent, which has the dissolved gases or the dissolved contaminant gases in the solvent. And this is another diagram or another like, more detailed diagram, how it looks like. So we have like a bed over here. You have the contaminant gas at the bottom. And of course the gas enter from the bottom because, has low density. And we have here a solvent go from the top, and both are meet here in contact to spend like, the resident time and increase the surface area of contact between both phases. And then at the bottom, the solvent extract the gas, or the gas is dissolved in the solvent and it go downward as extracted rich solvent, which has contaminant gas, and on the top has a clean gas out, or has a minimal um, or small traces of the contaminant gas, which is our target, by the way. So let's go to what types of absorption. We have two types. First type is a physical absorber. From its name, there is no chemical reaction happen between the solvent and between the contaminant gas. And of course, it's follow a Henry law, which is based on the solubility of gas and liquid. Example of that, carbon dioxide is absorbed by methanol, and of course, both can carbon dioxide is dissolved in the methanol, which is methanol is our solvent, and CO2 maybe one of other gases that we need to extract, and water vapor absorbed by TEG, which tetraethylene glycol. And this always we see it in gas treatment plant when we want to extract the water vapor from natural gas in general by tetraethylene glycol. And we have a chemical absorber. The gas react chemically with solvent, considered like very efficient because there is no way we can return back to the initial state. So is a reaction happen between the solvent and the gas and create another product. And of course, consider irreversible process. So I forgot to mention something. So in a physical absorber, it's considered like a reversible process. Why? Because the solvent and the gas, there is no chemical reaction happening. So it might be after the gas dissolved in the solvent, it can go to another process like a stripper, for example. So it can strip, the solvent and make it recycled back. So you regenerate the solvent back, and the gas itself you can get it as a separate stream, and you can use it in other process if you want. But in chemical absorber, you cannot do this because the gas that react with a solvent is creating another product, which can be regenerated, of course. For example, ammonia absorbed by sulfuric acid, and ammonia is as we see this in fertilizer companies, and sulfur dioxide can be absorbed by sodium hydroxide, and CO2 can be in amino treatment. Of course, that's in gas treatment plants. So how absorption work? Absorption work is a very simple uh, process. So first gas enter upward from the bottom of the column, and then the solvent meet them from the top, and then both are meet on fixed bed or backed bed or ration ring, where increase the surface area of contact between both phases. And then the mass transfer happen. So in case we have a physical absorption, so we care about the solubilities as the gas dissolve in this solvent. And in case of a chemical absorption, so we care about the chemical reaction or a chemical rate or reaction rate. Whereas the new product should be created and there is no way to return back to initial state. Treated gas leave from the top of the column, and the solvent or the rich solvent, we call it rich solvent because it's contain the contam gas. It's not a pure solvent anymore. Is associated um, with the contam gas or the gas you target to remove from the gas mixture um, you want to clean. And then, in case of physical absorption, solvent can be regenerated. Why? Because you see, as we mentioned, is reversible process. So the solvent and gas can go to a stripper where we're using heat, so we can strip gas from the solvent, and the solvent can recycle back to the absorption column again and um, use again as a pure solvent, or has a little bit or traces of the contaminant gas. So let's go to properties of solvent. Of course, solubility should be select a solvent that the gas could be dissolvent, should be dissolvent, because if it's not the gas not soluble in this solvent, so there is no point of absorption at all. For example, like ammonia and water. So ammonia can dissolve in water, and this help in the physical absorption. Vapor pressure. The vapor pressure of the solvent it should be low because to avoid losses. The activity in case of physical absorption, you don't need the solvent to be reacting with the gas. But in chemical absorption, it's okay. It should be. The solvent and the gas should be reacting together. Density is affecting the contact between both phases. Viscosity, of course, if the viscosity is high, um, of course, it's gonna work is acting as a resistance between the solvent and the gas. So the mass transfer or solubility um, is gonna be in a low rate. Of course, selectivity. Of course, the solvent should be selecting the gas that need to remove from the mixture of gases, and thermal stability, of course, to avoid solvent degradation, because we need solvent to has a good lifetime and stay for a long period of time and of course it's saving money, saving operating costs, and of course has low corrosivity because this at the end of the day, these liquids, these old streams are working through equipments. So you don't need this equipment and these pipes to be corroded by a solvent you're gonna use for a long time. So you need to select a solvent that has low corrosivity, so your equipment and your fitting and your pipe can live longer, and you save, of course, saving money. And of course, you have to care about safety and toxicity. So a cost should be like economic is okay. You affordable to buy this equipment and affordable to buy this solvent, so you can use it for a long run. Um, Regenerative, like you can regenerate back the solvent. For example, as I mentioned, like the ammonia and water, we can both go stripper and we can get the water back from from the ammonia and used back in the absorption tower. This is like a simple diagram. How is a reversible physical absorption and irreversible chemical absorption? So gas can go to solvent, no reaction, dissolving in a liquid, and gas here is reacted with solvent, is a chemical bound product, so there's no way to go back to initial state. But in a physical absorption, I always stress on this. If we add some like we add some heat to the mixture of gas and solvent, so we can regenerate the gas and regenerate the solvent as well. To sum up, an absorber is a tower where gas is cleaned by a liquid. Physical absorber, no chemical reaction based on solubility and Henry law, of course. Chemical absorption, gas and solvent react and create a new product which is hard to return back to initial state. Um, we can absorber remove gas components, stripper remove them from solvent. Yeah, stripper is always like a process to remove dissolved gases in liquid in general. And of course has many applications using refineries, gas plant, and any other sectors, of course. Thank you, and if you like this video, don't forget also share and like, and see you next video. Thank you so much.